Here's the 2.5, 2.7 Quest review. On this scatter plot, remember to put in the scatter plot into L1 and L2 for the electricity. So let's take a look at our first problem here. You should have gone ahead and plugged this into the calculator and come up with a similar function to y equals your your ax plus b, and your a should have been around 0.51 x, and your b should have been somewhere around 127, or 1.266, we'll round it to 127. Correlation, your r squared value should have been near 0.81, which is a strong correlation. In other words, it's fair to say that the electric bill goes up and down as the average temperature does. On number 2, a nationwide club begins a chapter near you, and all we had to do here was find out which one of the solutions here was correct, and as you use the linear regression, you'll notice that this version here, it should have been closer to 322, and 5104 should have been your values for A and B. What you also should have done was realize that since this is going to be your A value here, it would have been this situation, which only rules in B and C. A and D don't match that setup. And then when you plug in 39 years, because that's how long it was from 219 to 1980, into your function, it's going to spit out C right here. So you would have put in 39 years into this X right here. This here graph is of y equals x minus 3, and we had to translate up 2 units. And I said be careful for a reason, because if you look at these tick marks, each one of these tick marks represents 2 instead of 1. And if you want to go ahead and raise this up, this is at 3 right now. If you want to raise that up 2, it's going to be up to negative 1 here. So the only one that actually fits that scenario is this one right here. The letter is C. That fits in right there at 1. C was your correct answer. For number 4, scooch this up a bit, they give you just a basic function, and to shift it to the left 4 units, you should have written f of x being shifted to the left plus 4 units. Let g of x be a reflection of f of x in the x-axis. That means we have to take the opposite of the parent function. Now remember, this is the parent function right here. That's just the shift. So you should have had g of x equals negative x squared plus 3. You have to take the opposite of the entire parent function. This is different than putting a negative inside. You're taking the opposite of this whole parent function, then shifting it 3 up. The next one, write an equation that is a vertical compression by a factor of 1/4. Well, I'm going to take my function y equals x and then compress it by your a value of 1/4. Number 7, function f of x equals x squared. The graph g of x is f of x translated up 6 units, down 5. So I'm going to take this parent function, again, what I'm going to do, this is just a function notation, take that parent function, shift it to the left 6, in other words, remember, Horizontal means you're taking the opposite of what you think it is. That's going to be a plus 6. That's squared, and then down 5 units. Number 8. What transformation change is there from f of x to g of x? Here we went from 3 to 9, so we had a factor of 3 here, so that's going to be a stretch of 3. And if you look at your candidates here for your answers, A and C are the only ones that have a vertical stretch by a factor of 3, and this means go down 4 units. This is up, so we don't want that. We want C. Translated down 4 units. Number 9, what is the graph of the absolute value of x minus 5? Well, that's a shift down 5 units, so originally the parent function here is at 0, 0. I'm going to go down 5 units, and then I'm going to go ahead and use my slope, 1 over 1. So that's going to be here, 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 also here, 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 and just draw my lines. Wish they were more straight. Next one. Oh, you could have also gone ahead and put in a t-chart, put in the Fab 5. Whoops. Let's erase that here. -2, -1, 0, 1, 2, and you would have still come up with the same graph. Making sure you're plugging those values in. Number 10, we need to graph the parent function. Let's just draw the parent function here. I'm going to go ahead and change the color here a bit. The parent function is going to start off here at 0, go up 1 over 1, and I need to move that to the left 5 up 2. So I'm going to go to the left 5 up 2. And go ahead and put in the up 1 over 1. And there is our new translated function. Again, over 5 up 2. Number 11, compare each function with the parent function without graphing. What are the vertex, axis of symmetry, and the transformations? Well, this one is a little bit different. If you remember looking at the book, if you ever did see any of that, or from the previous notes, what we're going to have to take care of here is this negative for the x, and since we have 4/5 on the inside, we have to treat it a little bit different. We have to think about our a value being under our h value here. So if I were to go ahead and kick all this out, my a value would have been, so by the magic of technology, I went ahead and wrote this down real quick. If you were to take that a value out, in other words, factor that out, you'd be factoring out a 4. Now remember, when you multiply this back through, this would become negative 4x, or yeah, negative 4x, and 4 times 5 is going to cross those out, and you're left with your 5 right here. So now, with this factored out, our h value is going to equal negative 5/4. Our k value is going to equal 4. That's our vertex. Sorry, that should be a positive 5/4. Comma 4. That's our vertex. Axis of symmetry, that's always your h value. So it's going to be the line that is vertical at 5/4. And the transformation to the parent function is a stretch of 4. And a shift to the left, 5/4. Shift up 4 units. And remember, this is the opposite of the x value, so it's going to rotate, it's going to reflect over the y-axis. Number 12 says, what is the equation of the absolute value function? Again, through modern technology, we have our format here that we need to fill in. Well, we're going to have our y equals our a value. Now remember, our a is our slope. This one's a little bit tricky, so you have to be careful here. Remember, this is going to go down 1 right here, 2 to here, and over 1. So it's down 2 to the left 1. Our h value is going to be our horizontal shift of -8. So that's going to be x. Remember, do the opposite. And our k value. Our k value is down 1.5. To make this look pretty, there you have it. Good luck on your quest.